Welcome and good evening, students, colleagues, and friends. In this video, I will use lm command to run linear regression in R software. In the previous video, that is in video number 550, I used the regression command to run linear regression. So, as I mentioned, in this video, I'm going to use lm command to run linear regression in R. Kindly watch this video up to the end so that you could learn the complete procedure of running linear regression using the lm command. So let me start with the R. This is how R looks like when you open it for the first time. So first of all, we will open new file by clicking file and then new file, and after that R script, and this will create a text editor window. So this is the text editor window. Below this text editor window we have console, and to the upper right we have environment, and here in the bottom right we have tabs like files, plots, packages, etc. Now our aim is to run linear regression using lm command. Okay, so first of all we will have to install from install packages read R. So our we will create or install read R in the following way, and for that we will have to write this command install packages, and within the parentheses we will write read R. Since I have already created, so I don't need to reinstall it again. So I'll just go down, and instead I'll use library, and this read R. So I'll run it. Since I have already installed it, so I'm just using this command library and within parentheses read R. This I am loading because I'm asking R software to read my file and to read my directory, working directory, and then file. So it's working. After this I will have to set working directory, and to set working directory the command is setwd, which is the abbreviation for setting working directory, and for that the command is that I'll use this, and within parentheses I'll give the whole path. For example, my my directory is here in this D, and the name of the directory is underscore R training. So if I click this, if I run this, it says set working directory has been set. There is another way of setting working directory, and for that we will have to use session and then set working directory and go to choose directory. Since my directory is in D, so I'll click on this, and after that I'll open. So again, this is also another way of setting working directory, and the working directory is underscore training, and that is in D. After this I'll ask R square to read my file from CSV format, and I'm going to give it a name HSB, and after that read underscore CSV, and within parentheses and inverted commas the file name is ABC, which is in CSV format. So if I run this command, it will load HSV. So HSV is here. Since I am using this data, there are 11 variables in this file, and there are 200 observations. Let me show it to you. You see, the first variable is that of ID of the respondent, then gender. This one stands for female and 0 for male. Then there is race. There are 4 types of race. Then socioeconomic status 1 to 3. School type, public and private. Program, there are 3 programs. Then these 5 variables are numeric variables, quantitative, and these are various scores of reading, writing, score of math, score in science, and score in social study. So I'll be using linear regression of say for example math on read first, and then linear regression of math on write in the second model. So this is the whole idea. So this is a HSB. After that, I'll show the scatter plot of math and reading score. So I'll write scatter with S capital and P capital in plot, and after that I'll use the 2 variables. My first variable is math, comma, and second variable is reading score. And after that I'll give math, and my data set is say for example HSB. So HSB. So if I do that, if I run this, so here is the scatter plot of math and read. So as reading score increases, score in math also increases. So there is a positive relationship between the 2 variables. So math is a dependent variable and reading is the independent variable. After this, I would like to create first model in which I will regress math score on reading score, and for that the command is rec model .2, and then this command and lm, and after lm I'm writing math tilde and read, and my data is equal to HSB. So here I'm asking R to create a model that I title as regression model .2, and then followed by lm command, and within parentheses my dependent variable is math score, and my predictor is reading score, and I'm specifying data as HSB. So clicking on run, it has created a model for me. Now I'm going to ask R to show me summary statistics of this model. So summary, and within parentheses I'll use the same model, regression model .2, and if I run this, here are my results. So let me share these results with you first. So I am starting from here. These are my regression results. Let me show the result to you. So first of all, it is giving me Pearson product moment correlation between math score and reading score. The analysis has used all the 200 observations, and it has given me simple correlation of math and read that is equal to 0.662. So we are also going to test this hypothesis that there is zero correlation between reading and math score, and its t is equal to 12.438, degrees of freedom is equal to 1.198, and its p value is 0.00, and the confidence interval is this. After that, this is the residuals. This is the minimum of the residual. This is the first quartile, median, third quartile, and maximum. And after this, we have the estimated model. And here is the estimated coefficient of the y-intercept, and that is equal to 21.038. Its standard error is equal to 2.58. Its t value is equal to 8.125, and its p value is 0.00000, and then at the end you can see 0.476, and this is highly statistically significant. The regression coefficient of the predictor variable reading is 0.60515, and this is its standard error, this is its t value, and this is its p value. And after this, this is the residual standard error, which is equal to mean square error in stata, and here the name for mean square error is root mean square error is residual standard error, and this is equal to 0.037. This is the multiple r squared, that is equal to almost 0.44. This is the adjusted r square, this is the unadjusted r square, this is the adjusted r square. And finally, we have the F statistic, which is equal to 154.7 with degrees of freedom 1 and 198, and its p value is 0.00000, and at the end you have you can see 22. After this, I would like to show you another model, and that model is I will create another model just like I created model 2. Now this is model 3, so let me give it a name, reg model dot 3, and I'll give this command lm, and within parentheses I don't need this here. Within parentheses I'll give the first the dependent variable math, but this time instead of running a regression of math score on reading, I'm running linear regression of math score on write, and comma, and after comma I am telling R to use data set HSB, and if I run this, it has run this regression. Okay, and I'll show you summary statistics of this model, reg model dot 3, and run it. So it will show me the regression results of math on write. So let me also share this with you. This is the linear regression results of math on write. These are the residuals: minimum, median, maximum, and then we have the first quartile and third quartile, and these are the coefficients. Again, this is the coefficient of the y-intercept, which is equal to 20.43. This is standard error, this is t value, and this is the p value. Similarly, this is the regression coefficient for predictor variable right, that is equal to 0.61, and this is the standard error, and this is the t value of the predictor variable, this is the p value. This means that if the writing score increases by 1 point, score in mathematics increases by 0.61 points. After this, I would like to show you the root mean square error, that is equal to residual standard error, and its numerical value is 0.7.388 with degrees of freedom 198. The r squared value is equal to 0.381. The adjusted r square is 0.378. This one is unadjusted r square, this one is adjusted r square. F statistic value is equal to 122 and its p value is 0. So since this value is less than 0.05, so we conclude that the r squared value is significant and the overall equation is significant. Earlier I showed you the scatter plot of reading score and math score. Now I am going to show the scatter plot of math and write. So I am using S as capital in scatter and P as capital in plot, and after that I'll write math, and then instead of reading score I'm going to use write, and after comma I'll write data is equal HSB, that is R should use this data, and if I run that, then this will change into math and write. So let me see. Okay, SCATT. Sorry for this spelling mistake. And now if I do that, this should change. Run it. Yes, now the scatter plot has been changed from math and read to math and writing, and this also show exactly the same results, not exactly the same but almost the same, and it says that as the writing score of a student increases, the math score also going to increase. There is a positive and linear relationship between the two variables, where math is a dependent variable and writing score is a predictor or an independent variable. Math is also called as a response variable. So this is how we can run linear regression in R using the LM command. We can also find the same results by using a regression command that I have already shown in my previous video, that is video number 550. Ladies and gentlemen, this is very simple and I hope this was very helpful to you. If you have any question, you can ask me a question in the comments below to this video, and I would like to try my level best to come up with the answer. Thanks a lot for watching this video. Kindly subscribe to the channel, and don't forget to click on the bell icon so that you can get timely notifications about my other videos that I'll upload for you. Thanks for watching.